All right. Now what we have is we start out with this chart, and it's called Powers of 10. And what I'm going to do is, if you'll buy into this idea, if you'll buy into how this works, you'll say to yourself, well, I know how to do that because my number system is based on powers of 10. The money system is based on powers of 10. And so if the metric system is based on powers of 10, yes, I should easily be able to understand it. And that's what I want. I want everybody in here to be able to easily understand it. It's not going to be something, oh, I hate that metrics. No, you're going to want to use it. Except for Burma, Myanmar, and the United States, the whole world uses it. You can't stick your head in the sand and say, well, I don't like it. It's just weird. The rest of the world uses it. Okay, everybody ready? Here's what we did yesterday, and I got to find out who I called on because I said I would try to call on everybody. You what?
I want to do it.
Okay, all right.
Yes.
Thank you. A volunteer, that's even better. Man, that's even better.
Oh, yeah.
And you're right, I didn't call you. Are you ready?
Yeah.
All right. Matthew, I got some questions for you. And here's what I did yesterday, okay? How many of these does it take to make one of those?
10,
How many of these to make one of those?
100,
How many of these to make one of those?
1,000,
How many of these to make one of those?
10,
How many of these to make one of those?
100,
How many of these to make one of those?
1,000,
How many milligrams does it take to make how many micrograms to make a milligram?
1,000,
How many millijoules or microjoules to make a millijoule?
1,000,
How many micrometers to make a millimeter?
1,000.
It's the same answer, isn't it? And so what you thought was weird about the metric system, it's not. It's that thing in front tells you where you're at on this chart. Now we want to get more advanced today, don't we? Let's get a little bit more advanced today. And can you keep going?
Oh, I got
Okay, ready?
Got it in them.
Yeah.
How many of these does it take to make one of those?
10,
How many of these make one of those?
100,
How many of these to make one of those?
10,
What is it?
10,
How many of these to make one of those?
100.
How many of these to make one of those?
Is it a million?
It is. Now, what we want to do here, I want these numbers right here, just like that. When you see 10 to the 6th, you are going to say a million. When you see 10 to the 9th, you are going to say what?
Billion.
All right? And if you see 10 to the 3rd, what are you going to say?
Thousand.
Okay, now let's get a little more advanced. If I say, what's 10 to the 7th? You say, wait a minute. 10 to the 6th is a million. So 10 to the 7th is what?
10 million.
That's what I want. You see? So, what's 10 to the 12th? And here's a neat memory trick. Tera, trillion, 12. Whoa. Now I can remember that one. Tera, trillion, 10 to the 12th. Ready? What's 10 to the 11th? Wait. It's not quite a trillion. What is it? What is it? 100 billion. Yes. 10 to the 2nd. 100. 10 to the 4th. Wait a minute. 10 to the 3rd. 1,000. 10. See? And if you'll do that for me, I can teach you scientific notation like that. Now here's another thing. See, I'm looking for patterns. When you see patterns, you don't have to memorize so much. I noticed that the number 100 has how many zeros?
2.
That's 10 to the 2nd, isn't it? And I know you had a teacher somewhere. I know they did. They did this. Well, the reason 10 to the 2nd is 100 because you write down 10 twice and multiply them. 10 times 10 is what? That's why 10 to the 2nd is 100. Isn't that what your teacher taught you that? Okay, so how many zeros does a million have? So it's 10 to the 6th. What about a trillion? How many zeros?
12.
Oh, I get this. Now, you got to watch out for a pattern because sometimes students try to make up a pattern that's not really there. What's 10 to the 3rd? What is 10 to the 3rd? 1,000. What is 10 to the minus 3rd? Here's the good stuff. 1,000. What's 10 to the minus 6th? Wait a minute. 10 to the 6th is a million. So 10 to the minus 6 is a millionth. Yay. What's 10 to the minus 12th? Yes. Wait a minute, that's kind of making sense to me. What's 10 to the minus fourth? A little harder. Well, 10 to the fourth would be 10,000, so 10 to the minus fourth is a 10,000. Now, here's you gotta get careful. 100 has 2 zeros, but what about 100th? Oh, it's got 2 to the right of the decimal, but only 1 0, doesn't it? How many zeros 10 to the minus 12 have? Yes. It has 11 zeros and a 1, doesn't it? Are you with me? All right. Now, on this chart, excuse me, I think somebody, did I ask you yesterday what kind of numbers these were? Is this the class I asked that of? Okay. Look at this chart here. What percent of these numbers are positive numbers?
All of them.
What do you think?
Oh, wait, 50%.
And because you've been in school from first grade or kindergarten on, you're going to tell me about 50%. But I promise you, every one of these numbers is a positive number. Every one of them. Now, do you see this number here, 10 to the 0? What is 10 to the 0? 1. What is x to the 0? 1. What is b to the 0? What is anything to the 0? Okay, I can remember that. Now, if that's the case, then what does this mean? What does this mean? 10 to the minus 1. I see a minus 1, and you're telling me it's a positive number. See, these numbers here, 1 and 10, 100. If I made a number line, and I had 0, 1, 2, 3, here's 10 to the 0. Wow, 10 to the first is way down here, and 10 to the second is way down there, isn't it? We know those are positive numbers. But I'm telling you, these are not over here. Where are they? Where are all these numbers? Where are they? Somebody should know. Ryan.
Just behind the decimal point. We're talking about where the numbers are.
Well, what do you mean behind the decimal point? On the number line, where would you put them? We know that all these numbers are that way.
Just slightly in front of 0.
Okay, and where do they go to?
Positive.
Yeah, so see all these? They're all right here. They are all between 0 and 1, aren't they? Now, I'm going to show you for the first time, maybe your teacher did this. Let me tell you why these are not negative numbers, okay? Here we go. This is a great little math trick. Everybody in here, when I first learned it, I wish somebody would have taught it to me much earlier. Yes? You know it?
Someone, I think, yeah.
Oh, what is
I
it?
know why.
Okay, go ahead.
All right, so, I don't know, I might be wrong, but I think the only way you can get a negative number with like a power or whatever, if that's what it's called, is if the number itself is a negative, not the power it's going to.
Okay, you're right. So a negative exponent does not mean a negative number. But what does it mean? So watch right here. Ready? 10 to the minus 1. Okay, now there's a little trick in math. Hey, you know what? I don't think I like you up in a numerator. I'm going to make you go downstairs. I'm going to make you go down into the denominator. Oh, all right, but wait. If you make me go down to the denominator, you got to pay a price for that. What price is that? You have to change the sign of the exponent. Okay, so bring this down here. What did it become? Did I change the sign of the exponent? So 10 to the minus 1 is the same as 1 over 10 to the first. What is 10 to the first? 1/10. That's right. That's right. 10 to the minus 1 is 1/10. So if I was a math student, this is a neat little thing to do in math. Watch. What is x to the negative 2 divided by x to the minus 4? Wow. How do you do something like that? Well, sometimes your teacher wants you to change these to positive exponents. Let's do that. I'm going to make you a positive exponent because I'm going to throw you downstairs. And you are going to go up here. So now what's the answer? X what? What's x to the fourth divided by x to the second? When you divide numbers of exponents, don't you subtract the exponents? Don't you? Yes, when you divide numbers that have exponents, you subtract, right? So what's the answer? X to the second. Oh, let's go down here. What then is 10 to the minus 2 mean? 10 to the minus 2 is the same as 1 over what? 10 to the second. What is 1 over 10 to the second? Help me out. 100th. That's right. 10 to the minus 2 is 100th. That's not a negative number, is it? Are you okay on that? All right, what I'm going to do then is we're going to flip this over. This is not a quiz, but if I gave a quiz today, here's what I would do. Without looking, I want you to see how many of these prefixes you remembered from yesterday. So let's try it. If you remember, I'll give you the first one. How about that? I know that 10 to the third stands for kilo, and kilo has the abbreviation of little k. So I'll do the first one. I want you to do as many as you can without looking, and then you'll know which ones you have to study. Some of you don't know that you don't know these. All right, let's go. Oh, by the way, I ran out of space here, so I'm going to put a little bar here, 10 to the 12th, and I'm going to put another bar down here, 10 to the minus 12. I'm going to do that too, 10 to the minus 12. Okay, so see how many you come up with, okay? What's the prefix? What's the abbreviation? What's the prefix? What's the abbreviation? It's not a real quiz. I'm just seeing, do you know any of them? What if you said, I don't know any of these? Well, then I got to start making flashcards, don't I? Or how many you know? All right, do you remember nothing from middle school is coming back to you, right? Do you remember? Okay, now, when you have written as many as you know without looking, then go back and look and fill in the ones that you didn't have, okay? So if you say, I don't remember any, go ahead and start looking. Let's put these in there. It is interesting. I didn't know Sally. I'd like to know how many Sally knew. Do you know all these, Sally? Do you know any of them? Okay. Do you know a lot of them? Do you know at least 6 of them? Oh, good. Excellent. When you were in China, do they ever teach you about feet and miles and inches? Oh, they do. I'm surprised. Okay. Because I don't know why you need to do that, but. Did they ever teach you Fahrenheit? So, really? That's interesting. Okay. Okay, now be honest with yourself. Say, I know that one. I'm not sure about that. And if you're not sure, go back and look it up. By the way, if I were to give a quiz on Friday, and I am, this would be the first part of the quiz. You think you could do all right? It's only Wednesday. It's only Wednesday. You think by Friday you could do this?
Yeah.
I think you could. Where am I at? Oh, wait a minute. I put that in the wrong place. Oh, wait. I can't even read my own numbers. What happened to my 10 to the 9th? Dang it. Okay, sorry. I put that in the wrong place. 10 to the 6th. Mega Millions. Mega Millions. King, what's that thing? King what? King Henry died at drinking chocolate milk. Okay, I got that one. And Hecto what? Hecto 100? Hecto 100, yeah. Hecto 100. A decade is 10 years. And some books will say DEKA. Some books will say DECA. I'm not worried about that. So this one is deci. It has the decimal. That's 0.1. Here's 0.01. Centi. Here's milli. 0.001. 1,000th. Now we go down here. Ooh. This is really small, isn't it? 10 to the minus 6 meters, a millionth of a meter. What's that one? What's the abbreviation for? Wow, it's really small. I'd probably have to have a microscope to see that. What is it? Micro. And what's the symbol for the prefix micro? You make a U, and it's called a mu, isn't it? It's a Greek letter mu. And then we go down to, memory trick. Nano negative 9. Ooh, nano negative 9. And then what's 10 to the minus 12? That's small, isn't it? Anybody know that one? That's a hard one. Pico. Now, even though you might like Pico de Gallo, it's not a great memory trick because Pico de Gallo doesn't remind me of a trillionth of anything. You get it? So it's not a good memory trick. But if you can think of Pico, your Pico de Gallo was chopped so tiny it looked like a trillionth of something. Maybe that's a good memory trick. All right, hey, what do you think so far?
Are we just
Okay, as a teacher, I want to teach the prefixes first. The other ones are not prefixes, but they belong on this chart. And I'm going to do that in a minute. Okay. Now, is everybody okay on this? You say, that's my job. My job, if I have to make flashcards, whatever I have to do, I'm going to know these prefixes. And if you do, you're going to be in good shape. All right. Now, the next thing I'd like to do is flip this back over. Thank you, Ryan, for mixing it up. I want to show you two things on here. Yes. I want to show you two more things on here that are not prefixes, but I need to know where they are on the power of 10 chart. So, look right here. The story is right here. If you don't like me talking, you can go home and read the story right down here. All right. There are a couple of things I want to put on this chart that are not prefixes. They're distance units. See, micro doesn't mean distance. It means a millionth of whatever you put after me. A microgram is a millionth of a gram. But I'm going to have these two distance units, and I'm going to put them on this chart somewhere. They're not prefixes, though. Let me show you the first one. If you become a biology person, you will eventually read about these things that you see under the microscope. And they're tiny, and they had to measure them. So they started measuring them, and they're smaller than a millimeter. A millimeter is the edge of a dime. That's too big. So they had to go down here to the micrometer size. So, watch right here. A micrometer is a millionth of a meter, isn't it? Now, that's okay. There's nothing new there. Well, the biologists, and I wasn't around to tell them yes or no, but they decided to say, when I was in college, I remember seeing micrometer, and hey, that bacteria is 80 micrometers long and 40 micrometers wide. Because they actually have, do you know that in a microscope? You can buy a special eyepiece, and it has a ruler in it. And you take your other eyepiece out, put it in there, you look in there, and you see a ruler. And you move the ruler around and put it right next to your little cell, and you can actually measure how many micrometers long it is, how many micrometers wide. Anyway, it's kind of a neat little tool, all right? Well, I wasn't around, but the biologists did something kind of funny. They made the micrometer, they turned it into something new called the micron. Now, if you've ever seen any kind of science show, and they use the word micron, micron means the same as a micrometer. Now, I don't think they had to do that, but maybe people got tired of saying micrometer, right? And micron sounds pretty cool, doesn't it? So maybe it was something like that. Now, what's interesting is, guess what they use for the symbol for a micron? They used the plain old mu by itself, not as a prefix. So if I were to see a mu symbol by itself, it would mean micron, which is micrometer, isn't it? But if I see the mu symbol as a prefix, means something comes after it, then it means micro, doesn't it? Micro whatever. And they use that to measure the size of cells and things like that. Well, not to be outdone. Yes?
Wait, so can there not be like a micron meter?
No, that's a good question. That's a great question. Again, you might even say they were silly to do it. Why don't you just keep saying micrometer? I think they got tired of saying micrometer. And I think they thought it was cool to say micron. Now, I wasn't around when they made this up. Now, not to be outdone, there were another group of scientists who were measuring things way, way smaller than that. And they were even smaller than a nanometer. So, darn, I don't want to say it's 800 nanometers, so they did this. They made their own distance unit. 10 to the minus 10 meters. 10 to the minus 10 meters. That's a distance unit, isn't it? And they gave it the name angstrom. An angstrom is 1/10,000,000th of a meter. 1/10,000,000th of a meter. It's small. Now, what did they use this for? To measure the size of atoms. Atoms are measured in angstroms. Living cells are measured in something 1,000, 10,000 times bigger than that, called microns. So I'm glad you brought it up, Ryan. I do want the story's right down here. It's right here. If you want to read the story tonight and said, "Oh, after I read it, it makes more sense." But now I want to show you. I tricked you. I want to show you how many of you love to change one metric unit into another. How many people, if I gave you $10 and I said, "Here's 5 problems. Do this problem here." How many of you could do this problem right now? 1,042,000 millimeters equals how many kilometers? Can you trust me for a minute? I will show you how to do this, and you will never miss this again, as long as you know your prefixes. Got that? This is unbelievable, but it's just simple, and you know how simple it is. They just don't know. They act like the metric system stinks, but you know it makes sense, doesn't it? What do you think, Sally? It makes sense. Now, let me show you how to do this. Number one, what was the given? The given was millimeters, right? Now, you see milli? Put your finger on milli, on this little stair step. Find milli. There you are. Oh, there you are. I'll put it right there. And what do you want to convert it into? Millimeters into what?
Kilo.
Okay, all right. Put your finger here. Now, you ready? We need to take a trip. And we're going to go visit kilo. Now, you do not go up and down this stair step. You walk sideways. So you either go left on the stair step or you go right. Are you with me? All right, I'm going to go visit kilo. Ready? My finger went 1 to the left, 2, 3, 4, 5, 6. I saw my finger do what? It went 6 steps to the left. I saw it. Now, see this number here? I know what you're looking at. Some of you are saying, find the decimal. I don't know where the decimal is. If I gave you $1,442,000, do you think you might be able to find the decimal? You know where that decimal is, don't you? Don't you? All right, so the decimal's here, isn't it? Now, if you want to make this conversion, make the decimal move 6 steps to the left. What? Ready? 1, 2, 3, 4, 5, 6. 1.042. We're done. That is correct. 1,042,000 millimeters equals 1.042 kilometers. You know, for some reason, I don't know what it is. Maybe it's the way they teach in elementary school. A lot of you don't like the metric system. I think it's the way they teach it. I teach it completely differently. And this is unbelievable that you can do that problem and not sweat at all. It was like easy. And it's correct also. What do you think? Now, you know why you don't think this is true? Because if I did something in the English system, watch this. 8 feet equals how many inches? Is it going to be 8 and the decimal move somewhere? No, it's going to be some other number, isn't it? That's why you don't think this is correct. But look at it. It's the same set of numbers. It is the same numbers with the decimal moved, isn't it? That's the whole idea of powers of 10. If you, on a quiz, if you put some number like 65 here, that's ridiculous. It is the same set of numbers. Let's try the next one. You try it. Yes.
Oh, wait.
You want to try it?
Well,
Matt, you volunteered. You can do it.
So, it depends on what that is. So is that talking about a micro or a micron?
Okay, excellent. See
I
that?
think
Wait,
that's a micron.
you know what you just did? That is a crucial question. Crucial.
I think it's a micron because there's nothing after
Why?
it. Because there's nothing after it, it's not a prefix.
That's right. Prefixes never stand alone. Never.
So then would it be?
That's micron, isn't it?
Yes.
But where is micron on my thing? Well, it's actually in the same place as micro would be. So
then-
put your finger right here at where micro is. That's where micron, and micron's a micrometer. And where are you going?
Oh, I know what you said answer.
We're going to what?
Oh, I mean, we're going to nano.
Okay, let's take a trip. Ready? Everybody put your finger right here, 10 to the minus 6th. Let's go. Ready? 1 to the right, 2 to the right, 3 to the right. I saw my finger go 3 steps to the what?
Right.
I saw it.
880,000.
So, and I know what you're saying. Oh, there's no decimal point. $880 does have a decimal, doesn't it? You know where it's at.
Then
It's right here, right? But to make this conversion, I need to do what to the decimal? Okay, so that's right here, isn't it? So I got to move it 1 to the right, 2 to the right. That can't be it. It is it. It is it. Yes.
Can you re-explain?
Explain that again? Okay. This symbol here, the mu by itself, means micron. Micron is a micrometer. So I would start here on my chart. And a nanometer, that's also a distance unit, isn't it? And I'm going from micro, 10 to the minus 6th, and I'm converting to something that's 10 to the minus 9th. So I put my finger on micro, and then I go to visit a nano. 1 to the right, 2 to the right, 3 to the right. Now my finger went 3 to the right, so I need to move the decimal. 880, our decimal's right there, isn't it? I move it 3 to the right. 1, 2, 3. The answer is 880,000. All right. Yes.
So the micron micrometer thing is really a technicality because they are,
Well, be
Well,
careful.
like-
One of them is a prefix and one's not.
well, yes, but if you see them like this, if you're doing a problem like this, the steps are going to be the same.
Yes,
So,
that's true. You know what I would not be able to do? I would not be able to change microns into nanograms.
yeah.
So I have, this is a distance unit, and that's a distance unit, so I can make the conversion. But if it said microns into nanograms, I can't even do the problem. You can't change distance into mass. All right, Lauren, go ahead.
Can I try the next one?
What?
Can I try the next one?
Yes, I love this. All right, if you guys, if I'm a coach, I've coached a lot in my life. In practice, I want you to try things. I want you to try to get better. And if you make mistakes in practice, there's nothing wrong with that, is there? If you're going to make mistakes, let's do them in practice. If you're going to make mistakes, do them now. Don't wait till the test. Do them now. Excellent. Go, Lauren. Where are you going from? What's the little D stand for? And where's Deci? 10 to the what? 10 to negative 1. It's 1/10, isn't it? All right, where are you going? Deci to what? Okay, all right. Tell me how many steps. Now, you put your finger here. You don't start counting until you move. Ready? Oh, sorry. Come on, camera. Oh, frozen. Boink. Boink. All right, say it again. Does everybody get that? Is that 5 to the right or not? Okay, let's do it. 5 steps to the right. Okay, wait a minute, you're ahead of me. I'm gonna write the original number. Now move it 5 to the right. Let's try it. 1, 2, 3, 4, 5. Get rid of that guy. Put back my, come back with decimal. So, did you get 2,400? Can I know you're a teenager, and you don't want to say, I guess this makes sense. Does this make sense to you? Is this easier than you've ever done it before? The metric system? You have to know your prefixes, don't you? All right, it should be easier than you've ever done anything before, as far as this stuff. What's my time? Oh, they fixed my clock. Okay. All right, is it time to eat or not? Wait a minute, wait. What is today, Wednesday? Oh, Lynch at 11:25. All right, thank you very much. Hey, everybody know your prefixes by tomorrow, okay? Everybody know your prefixes by tomorrow? You can do it. You can do it. We don't have the quiz till Friday, but we have some more stuff to learn, though. We have some more stuff to learn tomorrow. Matter of fact, the quiz is the second half of the period on Friday, and we're going to review the first half on Friday,